So, what we're doing today is called completing the square. Completing the square is a process we can use to solve quadratic equations. It is good for certain problems, but not for all problems. So if it's something you enjoy doing or that you find easy, it's a good thing to know to do. For this class, I don't see many of you using this unless we tell you that you have to use it to solve a problem. So just keep an eye out for that on the test or the quiz. There will be problems where we say that you must solve it using completing the square. So, before we do a full-blown problem, we need to do a few exercises to get you in the habit of what we're doing. The first thing that I want to talk about is what the goal is about completing the square. It's to take it from one type of equation to another. This first type here on the left, ax squared plus bx plus c, you should recognize it. That's the standard form. And then we're changing it to this other form, a times x minus h squared plus k. You have seen this before back in Unit 2, but it's been a while. This we call vertex form. First off, we're going to do a little bit of factoring. These are a special type of trinomial called the perfect square trinomial. You'll see why it has that name when we do several of these problems. X squared plus 6x plus 9. So first let's label A, B, C. We'll factor with our ACB chart. A is 1, 1 times C, 1 times 9, that's just 9, and B is 6. 3 and 3. Three times 3 is 9. 3 plus 3 is 6. So we have x plus 3 and x plus 3 again. There is a better way to write this. Instead of writing it as two of the exact same factor, we can just write x plus 3 squared. Let's do another one, this time with a negative. X squared minus 10x plus 25. Again, we have our ABC. ACB chart. 1 times 25, that's 25, and B is negative 10. Now our options are limited here. It's either 1 and 25 or 5 and 5. And we know 5 plus 5 can get us 10. To get negative 10, they'll both have to be negative. Negative 5 times negative 5, that is positive 25. And negative 5 plus negative 5 is negative 10. So it's x minus 5. And x minus 5 again. And so we get x minus 5 squared as a final answer. So basically a perfect square trinomial, when it's factored, it's either x plus that number or x minus a number squared. That's how it will always factor. When we complete the square, we always want to end up with something that looks like this. This next section is practicing the completing the square step. It is a singular step, but when we're doing it in a full equation, it looks like a lot more than this. So when we complete the square, we're trying to create one of these polynomials like what we did in the first two problems. So you'll notice in all of these problems, C is missing. That's because we're going to find C ourselves. We're going to force it into a perfect square trinomial. So how we do this, we have x squared plus 22x plus a mystery number. We're going to figure out that mystery number using a little formula. It's right above here, b over 2 squared. So we have our a and our b. We're trying to find c. B over 2 squared. B is 22. Over 2 squared. 22 over 2, that's 11 squared. For this first one, I'm going to do more work than need be just to show you the little trick I use, show you that it does work, that you are convinced. After that, we're going to take a shortcut and we're going to not do nearly as much work. So for this first time I write it, I'm going to put 11 squared. That's our C term. Next, I'll write it as x squared plus 22x plus what this is. This is 121. And then we're going to factor it. ACB chart. A is 1, so C, 121. And B is 22. Now, if you don't already see it, the numbers are 11 and 11. (11 times 11 is 121. And 11 plus 11 is 22. So we get x plus 11 times x plus 11. And then as we did above, we can write this as just x plus 11 squared. The trick, and I'm going to do that on the next three, is once we figure out what that number is inside the parentheses squared, we can jump straight down to this last step because that number in parentheses is always going to be the factor. So we don't have to do this factoring portion. We're going to take this number and we're going to set it up like this, and that'll be our answer. Number 4, x squared minus 4x plus c. X squared minus 4x plus something. We're going to figure out what that something is. We have a, b, we're finding c. B over 2 squared, that's the little formula you need to know. B is negative 4 over 2. Negative 4 over 2, that's negative 2 squared. Keep the negative.
Just lose it in the square thing?
Not on this problem. But in an equation, yes. So let's put the negative 2 squared into here. Now remember, on the previous problem, when we did all of this work, we ended up with x plus 11 squared, and that 11 came from up here. So I'm going to jump straight down to this step, except for number 4. And I'm going to just write x minus 2 squared. We can go through and factor this, but this is going to be the result. So we're saving ourselves a lot of time and energy by recognizing this little trick here. Any questions on that? Okay. We're going to do that 2 more times. Number 5, x squared plus 5x plus c. X squared plus 5x plus something. That something is b over 2 squared. B is 5. 5 over 2 squared. Now when you have an odd number in the top of your fraction, obviously it's going to give us a decimal. The choice is yours on how you want to approach that. If you want to leave this as a fraction, that's fine. If you want to leave it as a decimal, that's also fine. This is going to be a nice decimal, so I'm sure most of you would prefer the decimal. So I'm going to use that. 5 over 2 squared, that's 2.5 squared. So we have plus 2.5 squared. And when we factor it, we have the x and the squared. And then we're just going to bring this number down, so x plus 2.5, whole thing squared. One more, number 6. X squared minus 8x plus c. So again, we're trying to figure out what c is. X squared minus 8x plus something. That something is b over 2 squared. So we have a and b. B is negative 8 over 2 squared. Negative 8 over 2 is negative 4. Keep it squared. Don't actually square it. That's going to go here. We're going to add the negative 4 squared there. And let's factor it down. We have x minus 4, whole thing squared. That is how it's going to factor. Any questions up to this point? Hopefully that felt easy, because this is kind of the obstacle to these problems, is understanding this step. So doing it this many times, hopefully it feels a little more normal to you. Let's do that in an actual problem. Here are the problems you will be solving by completing the square. So we have our equation. Very first thing you want to do before you start the process, again, make sure that in front of that x squared there is no number besides 1. If there is, you can't do this process. Once you've made sure that that is a 1 there, we're going to start solving. First thing we want is just the x's on the left side. So let's move the plain number, the constant, to the right side. That's a minus 11, so we're going to plus 11. And we get x squared plus 10x equals 11. After this step, we're going to complete the square. That little exercise we're doing on the front, finding that c, that's what we're doing. So we have x squared plus 10x plus something equals, golden rule of algebra, what you do to one side, you do to the other. So we're going to add that something to both sides of this equation. So we have b over 2 squared. We've got our a and our b. We're trying to find the c. This time b is 10. 10 over 2, that's going to give us 5 squared. So then we're going to add 5 squared to both sides of the equation. On the left side, this was the trick we talked about. We can rewrite this, we'll factor it as just x with the squared on the outside. And then this is a positive 5, so it becomes x plus 5 squared. On the right side, I am going to want to get this down to just one number, so I'll go ahead and turn this into a 25. At this point, I am done completing the square, and now I'm just trying to solve for x. So before I do the solving part, any questions? Okay, let's solve for x. Right side, we have 11 plus 25, that's 36. Bring down the x plus 5 squared. Before I do the next step, I'm going to write this down one more time. When you do this, leave some space in front of the 36. Reminder, the goal is to get x by itself. At this point, I have to get rid of the square. That's my next step. What's the opposite of squaring a number? Square rooting. We're going to square root both sides. On the left side, that's going to cancel out the square. So the square and square root, they're both gone on the left side. Right side, we'll take the square root of 36 in a moment, but there's something else. When you square root both sides, the side that just has a number on it gets a symbol. That is the plus or minus. That is always coupled up with the square root. So on the left side, we have x plus 5. On the right side, we have plus or minus 6. We're almost there. Don't lose sight of the goal. We have an x plus 5. Need to move the 5, so we'll minus 5 on both sides. X equals, don't combine these. This plus or minus 6 is actually two scenarios in one. I'll explain that in a moment. What we'll do is we'll write the minus 5 first, so negative 5, and then the plus or minus 6. To get our answer, we need to split this up because this is two answers, not one. So what this means, we have x equals negative 5 plus 6, and x equals negative 5 minus 6. And we need to get both of those numbers. Negative 5 plus 6, that's positive 1. Negative 5 minus 6, that's negative 11. So those are my answers, 1 and negative 11. I know that's a lot of work. I promise you with enough practice it won't feel like as much, but this is something you have to practice quite a bit. We'll practice more of it tomorrow.